Hi friends, how are you this morning? Hopefully you are all well. This morning we will discuss one of the Physics Olympiad selection questions. You can read this question for a while. There is nothing wrong if we watch this simple animation. Here is an inclined plane. Right at the bottom end of the inclined surface, there is a brick. This brick is moving through the inclined surface. It looks like the inclined surface is quite rough. The brick will eventually stop moving after reaching a point, then reverse direction. We are not asked to get the position from that point. We are asked to get the distance traveled by the brick, 1.3 seconds later. You can watch this video for a while to get inspired. Okay, let's discuss it. Distance is a quantity in motion kinematics. This quantity is measured against a reference. So, place this system into two-dimensional Cartesian coordinates. The upward inclined surface is the x-axis, and the vertical line perpendicular to the surface is the y-axis. The initial position of the brick is at the center of coordinates. As the brick moves, it gets some force. The downward force of gravity, due to the presence of the Earth's gravitational field. The friction force Fk, because the surface of the inclined plane is rough. And one more, the normal force N, because the brick does not penetrate the surface of the inclined plane. Of all these forces, only the gravitational force has a direction that is not in accordance with the direction of motion. We can decompose the gravitational force into component vectors that are in the direction of motion and perpendicular to the direction of motion. These forces will form the resultant force. We know that the brick is not moving on the y-axis. The resultant force in that direction is 0. N minus mg cosine theta is 0. Let's call this equation 1. For the x-axis, we will add up all the forces in that direction. Minus Fk, minus mg sine theta is equal to ma. This is equation 2. Both quantities on the left side are negative, so the sign of A is negative. The brick moves to the right, but accelerates to the left. The movement of the block will be slowed down. That is why the block will eventually stop at a point. The analysis of the dynamics of motion only goes as far as getting acceleration. After getting this value, we will analyze the kinematics of the motion of the brick. The block is moving in a straight line with constant acceleration. The corresponding kinematic equation is x equals x0 plus v0t plus half at squared. Since the block starts from the center of coordinates, x0 is 0. We can substitute the acceleration value. All the values on the right side have been stated on the problem sheet. We can calculate this value on a sheet of paper. If I am not mistaken, x at 1.3 seconds is 1.3 meters. It seems that at that time the block has reached its peak, and is moving towards the bottom of the inclined plane. Can you calculate the horizontal distance before the brick changes direction? Write your answer in the comments column. Happy learning, everyone!